Hello. So question says that consider the following reversible chemical reaction, right? Consider the following reversible chemical reaction, and this is the reaction. So now we have to tell that the relation between K1 and K2. Here are K1 and K2 are the equilibrium constant, right? So let's try to solve this question, right? So before doing this question, we have to understand the properties, or you can say the characteristics of the equilibrium constant, right? So I can write here as the characteristics of equilibrium constant, right? Equilibrium constant, right? Equilibrium constant, right? So it is the characteristics of equilibrium constant, that is K, right? So let us suppose a reaction, that is, suppose this is A gas which is in equilibrium with B gas, right? If I multiply this whole equation, right? If I multiply this whole equation by any number, suppose it is M, right? Suppose it is M and it is M, right? So the new equation, right? So before doing this, let's say it has equilibrium constant K, and this equilibrium constant K, that means, and if I multiply the whole equation by M, right? So the new equation becomes M A gas, right? So the M A gas which is in equilibrium with M B gas, right? So I multiply the whole equation with any number, that is M, right? So the new equilibrium constant becomes K dash, right? So the K dash is equals to K dash is equals to K to the power M, right? So this is the characteristics of the equilibrium constant, right? So this is the first characteristics, right? Now second characteristics of the equilibrium constant is that, let us suppose, if we have a reaction, right? If we have a reaction, that is A gas which is in equilibrium with B gas, right? Which is in equilibrium with B gas, right? So if I reverse, let's suppose it has a equilibrium constant K, right? And if I reverse this reaction, right? If I reverse this reaction, reverse, right? So it is reverse this reaction, then it becomes B gas which is in equilibrium with A gas, right? So the new equilibrium, let's suppose it has a equilibrium constant K dash. So the new equilibrium constant K dash is equals to 1 by K, right? It is equals to K dash is equals to 1 by K, right? So this is the properties of the equilibrium constant, right? So let's try to solve this question now. So now we have given the two reaction, right? Now we have given the two reaction, that is, now we have given the two reaction, that is A2, right? So the reaction is like this: A2, B2, and 2AB, right? So the reaction is look like this. So I'm just writing the reaction, that A2, which is in gaseous state, right, plus B2, which is also in gaseous state, it is in equilibrium with 2AB, right? For this reaction, the equilibrium constant is K1, right? For this reaction, the equilibrium constant is K1, right? And the another reaction is like this: 6AB, 3A2, 3B2, right? So I'm just writing the reaction, that is 6AB, 6AB, which is in gaseous state, right, is in equilibrium with 3A2, right? And this is also in gaseous state, and 3B2, right? This is also in gaseous state, right? So now we have, this is equation number 1 and this is equation number 2, right? So let's try to solve it, right? And try to apply the properties of equilibrium constant, right? So let's see, if I multiply the equation 1 by the equation, or you can say it by the number 3, that means I can write here as, if I multiply the whole equation is multiplied by 3, that means I multiply it by 3, right? So the new equation becomes 3A2, right, which is in gaseous state, plus 3B2, right, 3B2, which is also in gaseous state, is in equilibrium with 6AB, right, is in equilibrium with 6AB, right, which is also in gaseous state, right? So for this, the K dash, right? So for this, the new equilibrium constant becomes, I can say this, the new equilibrium constant becomes K dash, right? And we know that for this reaction, the K dash is equals to K1 to the power 3, right? So we have to use the property of the equilibrium constant, right? And let's say this, and if I reverse this reaction, right, if I reverse this reaction, right, so if I'm reversing this reaction, the reaction will be look like this. I'm just writing the reaction, that is 6AB, which is in gaseous state, it is in equilibrium with, right, it is in equilibrium with 3A2, right? It is in equilibrium with 3A2, that is 3A2, which is in gaseous state, plus 3B2, right, which is also in gaseous state, right? So for this reaction, right, so for this reaction, I can say that for this reaction, let's say it is K double dash, right? So the new equilibrium constant is K double dash, right? So the new equilibrium constant becomes K double dash equals to 1 by k1 to the power 3, right? Or you can say this k double dash, right? K double dash is equals to 1 by k1, right? So it is equals to 1 by k1 to the power 3, right? And we know that this reaction is similar to this reaction, right? Equation number second, right? So this reaction is similar to equation number second, right? So like this, right? So I can say this, the k dash is equals to, I can say this, the k double dash is equals to k2, right? I can say this k double dash is equals to k2, right? So from here I can say this, the k2 is equals to, I can say this, the k2, which is equilibrium constant, is equals to 1 by k1 to the power 3, right? 1 by k1 to the power 3, right? So this is the equation, right? And if I try to solve this, if I'm trying to solve this, it will becomes look like this, right? So I can write here as k2, it is equals to k1 to the power minus 3, right? So I can write like this, right? So this is the relation between equilibrium constant k2 and k3, right? So let's try to solve this question further and try to see the option. And option A says that K1, K2 is equal to 1 by 3, right? So this is not the right answer, right? This is not the right answer because we are getting K2 is equal to K minus 3, right? So this will be the wrong answer, right? And if I'm talking about option B, that is K2 is equal to K1 to the power 3, right? So but we are getting K2 is equal to K1 minus 3, right? So this will be the wrong answer, right? And here C is K2 is equal to K1 minus 3, right? So this will be the correct answer, right? And D will be the automatically wrong because K1 into K2 is not equal to 3, right? So we are left with only the correct answer is C, that is k2 is equal to k1 minus 2 to the power minus 3, right? So this is equals to that equation, right? So this is this equation, right? K2 is equal to k1 minus 3, right? So the correct answer will be option C, that is k2 is equal to k1 minus 3, right? So hope this answered your question. So thank you. Hello, so question says that the equilibrium constant at 298 Kelvin for a reaction A plus B, which is in equilibrium with C plus D, is 100, right? If the initial concentration of all the four species, right? If the initial concentration of all the four species were 1 molar each, right? Then the equilibrium concentration of D, right, in moles per liter will be, right? So we have to calculate the equilibrium concentration, right? So we have given a chemical reaction in which A plus B, right, is in equilibrium with C plus D, right? C plus D, right? So this is a chemical reaction, right? So we have to calculate the concentration of D at equilibrium, right? So we know that the initial concentration of all the species were 1 molar, right? So we can write here, right, at T is equal to 0, or you can say that initially the concentration of A becomes 1 and B becomes 1, right? And C becomes also 1 and this is the becomes 1, right? So when equilibrium reached, when the equilibrium, this is initially, right? So let us say that T is equals to 0, right? So T is equals to 0. At time T is equals to 0, this is the concentration, right? So when equilibrium reached, so the we can say that the X mole of C is formed. So I can say that when new equilibrium is reached, then we can say that X mole is X mole, right? So I can say that X 1 minus X, new concentration will be 1 minus X, right? And it becomes 1 plus X, and this is also 1 plus X, right? This is 1 plus X. This is the concentration when new equilibrium is reached, right? So I can say that this is T equilibrium, right? So but we have to find out the concentration of the D at equilibrium, right? So we have to find out this value, right? So we have to find out this value. For this we have to calculate the value of X, right? So here we know that the Kc, the equilibrium concentration constant, right? We know that Kc is equals to, we know that the Kc, right? Kc is equals to concentration of C, right? Kc is equals to concentration of C into concentration of D, right? Divided by concentration of A into concentration of B, right? So this is the value of Kc, right? And it is equals to 100, right? So it implies that the concentration of C, right, the concentration of C into concentration of D divided by concentration of A and concentration of B, right? So it is B, is equals to 100, right? So we know that at equilibrium the concentration of C and D is this, like 1 plus x and 1 plus x, right? And similarly for a and b, 1 minus x and 1 minus x, right? So I can write here as 1 plus x, right? I can write here as 1 plus x, right? So it is 1 plus x, 1 plus x, and this is also 1 plus x, right? Divide by 1 minus x, and this is also 1 minus x, right? And this is all equals to 100, right? So if I further solve it, then it becomes 1 plus x whole square divided by 1 minus x whole square, right? And it is equals to 100, right? So if I further solve it, it becomes 1 plus x, or you can say that taking the square root on both sides, so we get 1 plus x, 1 minus x is equals to 10, right? So here I can say that the value becomes 1 plus x is equals to 10 into 1 minus x, right? So 10 into 1 minus x, right? And so if I simplify it, I will get 1 plus x is equals to 10 minus 10x, right? 10 minus 10x, right? So this is 10x. So similarly, I can say that if I solve it, then I will get x plus 10x is equals to 10 minus 1, and it is equals to, you can say that 11x, right? It is 11x, right? This is 11x and this is 9, right? So I will get the value of x is 9 by 11, right? So it is 9 by 11, right? So but we have to find out the concentration of D, right? So we have to find out the concentration of D at equilibrium, and this is the concentration of D at equilibrium, right? So I can say that the concentration of D, I can write as concentration of D at equilibrium, right? At equilibrium is equals to 1 plus x. So I can say that 1 plus 9 by 11, and it becomes 20 by 11, right? And if I solve it, so it becomes 1.818, right? So this is the concentration of D at equilibrium, that is moles per liter, right? So this is the concentration, right? So let's check the option, and options are 0.818, no, this is not the right answer, right? And 1.818, yes, this is the right answer, right? So this is the right answer. Option B is the correct answer, and the 1.182, this is not the right answer, and 0.182 also not the right answer, right? So we are only left with answer B, which is 1.818 moles per liter. So this is the concentration of D at equilibrium, right? So hope this answered your question. Thank you.